Okay. Anything else from, yeah?
I know you're about to talk about grades, but how can we view our grades?
Say again?
I know you're about to talk about grades, how can we view our grades?
Oh, okay. Come see me. After the second test, I'm gonna start giving out a grade sheet summary. It's gonna have all the grades on stuff that's for you, it's gonna have your current average, it's gonna say what homework I think I'm missing, and then it's gonna say what your grade would be if you turn in no homework, if you turn in all the homework, if you made test corrections. Yeah.
So just wait.
You can either wait for that, or you can just come see me anytime. It's crazy. I like the old school way of just, hey man, can I see my grades? Great. So real quick, I know a lot of people use Canvas for grades. Canvas makes mistakes, and one of my I can't remember if I told you about this, but one of my colleagues had to tell our entire class that their grades were actually lower than what Canvas said. Because Canvas sometimes makes assumptions about things, and it's not easy to catch all the things you have to like turn off, so it doesn't make certain assumptions. And that, I don't want that to happen. I'm like, if I make a mistake, I want it to be me, not some crazy computer saying, hey, you're all doing great. You guys kind of with me? So I do not like to use Canvas for grades. That does not mean I hide grades. You guys can always just come see me. Sometimes I'll bring my thumb drive with me. I can start doing that from now on if you want. Before class, I can just show you your grades, right? Yeah. Anything else? Oh, hey. All right, guys. Anything else? Yes.
Yes, 4, where it says the situation described below involves action.
Yeah. Which version did you have? You had.
Ella raised $5 for the school fundraiser. And then Ella raised.
Oh yeah. Okay. So obviously, does that involve a comparison or not? Huh? You have two people, and you have differing amounts between them. So this is completely a comparison problem, right? So what I need to see then is like two visualizations for, one for each person. And then you had the one where it said, how much more did Alberto raise? So to be honest, I was sort of leaning on that one because you can look at it two different ways. So either the takeaway or the missing add-in. I was kind of leaning towards missing add-in, but are you guys with me? That's number 4 on the quiz. Does anyone have any specific questions about how to set that kind of thing up, or you guys? Okay.
It's like where you have like what the one person has or the other person has, and it's like 5 plus what you paid for that.
Yeah, you can do missing add-in. Totally. But the way I worded that one, I would have taken takeaway also, because there's one where I said, how much more does Ella need to make to have the same as whatever? That was much more like in your face, missing add-in, right? Yes.
I'm sure you've explained this before, but I forgot. How does the correction points work?
Oh yeah. If you get an 80 or above, and you do all the corrections and get them all right, you can get 5 points back up to 100. Right. So you get 81, you get 86. If you got a 97, you get it up to 100. If you got below an 80, you get 1 point for every 4 points you missed. If you get them all right, you make all the corrections, right? So you got a 72, you missed 28 points. That's divided by 4 is 7. You could get 7 points back. Math. That's silly. So there are several tutors who are tutoring. There's one more person I got to add to the list. Eventually I'm going to remember to do that. But on Canvas, there's a list of all the tutors. You can come see me and say, I'm not turning this in. Can you tell me if these corrections look okay? And then I'll tell you. And then if I have time, I'll actually help you with any that don't look okay. It's great. And the tutors will do something very similar. So get help with corrections. It always hurts me a little bit when somebody turns all these corrections in and they get 0 points back. right? So you'll never get below your grade. You with me? And I really want to make sure you understand that, because if there's something I didn't take points off of that I really should have, you can still turn. I'm not going to suddenly go, oh yeah, I should have taken 5 points off. No, I'm not going to do that. That was my mistake in the first place. You guys with me? So don't hesitate to turn in some corrections. Anything else about corrections? What do corrections do? Everything's due the day of the, except homework corrections. Homework corrections are due the day of the. Fine, yes. I want to see something. Do the end of the decade, Jeff. No. Yes.
What does an S stand for?
Where are we at?
You wrote average, so maybe.
Oh, I'm sorry. I talked about this a little bit before, but this is like the spread of the data. It's actually called the standard deviation, but it's just a number that tells me how spread out the numbers were from the middle. And normally for quizzes and tests, it's like 14, 15. So this is kind of a big spread. And from the distribution, you can kind of see why that might be. So I had some really high A's and I had some lower F's, so that kind of makes the spread big. Yeah. So again, just to show you an example, real quick, guys. Say you got like a 20 on a quiz. How many points did you miss? 80 divided by 4 is 20. I can do 20 plus 20, you get all the way up to 40. Watch out, celebration time. You with me so far? You get all the corrections right, tell me your grade, but it's still a 40. You're like, ooh. You take the test, you slept the night before, you ate breakfast that day of, you studied, and you get like an 83. Your quiz grade becomes a frickin' 83. Do you understand what I'm saying? If you correct a quiz and you do better on the test, your quiz grade can go up again. I do it kind of proportional to how many corrections you got right. If you got half the corrections right, I'll average it halfway. If you get a higher grade on the test. Do you guys understand what I'm saying? Why do I do that? I don't know. Oh yeah. If you miss a quiz, who knows what happens? You're SOL. No.
Takes up the text.
The test grade also counts in place of the missing quiz grade. So your test grade just counts more. You with me? If you think about it, that's not fair to the people that took the quiz unless I make it possible for them to make their quiz grade become a test grade. So I'm trying to make all my stuff wash out in the end and be fair. This is very interesting from your perspective because, I mean, you can certainly look at some stuff I do and go, well, I'm never going to do that weird ass shit. You know, so now you can start analyzing your various instructor syllabi as, should I do that kind of thing? Now, of course, you're going to be dealing with different ages, but there are general thought process behind syllabi that you can start to consider for yourself, right? How to grade stuff, how to put it all together in the end. Okay. Anything else? Yes?
6, I have the 2 base 8, they're in base 8 form.
Oh yeah. So there's an idea that we've looked at. I should do it up here since I got the guy going. About like what happens with 9 plus 2. What's a good way to show a student who's just learning this stuff what 9 plus 2 is? What's 9 plus 1? 10. So what's 9 plus 2? It's 9 plus 1 plus 1. You with me? So normally students get pretty quickly how to get to 10. In fact, we call those compatible numbers. 3 plus 7, 4 plus 6. It's kind of like quickly gets in the head that those numbers go together nice. So if I can teach your students, if you have something to add like 4 plus 7, well that's 4 plus 6 plus 1. Get to the base and then see how much more you got. You with me so far? So that's for base 10. For base 10, I want to get to 10, 8, 9, 10, and then see how much more. Base 8, I want to get to 8, which would be 1, 0, and see how much more, right? So for example, I say that as if I'm ready for this. Let me see, hold on. Yeah, good, okay.
Oh my gosh.
O, A, 2, 1, no, do not show again. I don't know what that means. Go away. Don't show again. Stop it. Okay. So if I have like, let's try this, 4, ooh, blood red. 4 base, 5 plus 2 base 5. Right? So a student can do this, you can tell a student, okay, 1 base 5 plus 2 base 5 is 3 base 5. So what's 4 base 5 plus 2 base 5? You couldn't fault them too much if they said 6 base 5. So that's kind of like what this is talking about. That's a mistake you could make. And a lot of you guys were I like the way you put it, because it's the way you have to explain to your student. What number are you looking out for that you'll hit in base 5? 4, so really 5, 1, 0, right? So in base 10, I'm looking when am I gonna hit 10? That's gonna be when I start to kind of like, that's gonna be where I stop and then I see how much more I've got to go. So I gotta do 9 plus 3, 9 plus 1 is 10, I got 2 more to go. So I get up to the base and then I see how far past that I wanna go. So if I'm gonna add 2, how can I rewrite this? So I hit the base. 1 base 5 plus 1 base 5, right? So these together make what? 10. So then I get what? Yeah. Which is exactly how you tell a student how to do something like 6 plus 9. 6 plus 9 is 5 plus 10, 15. Right? Make the base and then go from there. Go ahead.
Like for the 8,
So what are you looking for? You're looking to get to 8. And what's your second thing say?
7 base 8 plus 2 base 8.
Oh, okay.
Base 8.
So how much does 7 need to become 8? And how much is left over? Because you want to add 3 total.
So 2.
There you go. Does it make sense? 9 plus 3, 1 makes it 10, 2 left over, 12. 7 plus 8, 3 makes 7, 10, 5 left over, 15. Maybe. So you could call that method make the base. Yes?
How do you draw missing atom?
Oh. See, that's the kind of question I want. You're not going to work with me. There you go. About that problem. Sorry, I didn't mean to make everybody else feel bad. That problem, I was trying to see if anybody needed help with how the hell do you represent visually something like this and that. So let's say I have, somebody's got $4 and they want to have $7. With me? So Ella's got $4. She needs $7 in order to buy this thing. How much more money does she need? Right? So here she is with her $4. And then you literally are, what are you missing to make 7? So then you count on 5, 6, 7, and then you say, oh, 3, I'm missing 3. That is a pretty good way to represent missing added. Is that the only way? No. That's the way I know, that's the way I think of when I think about how to represent missing added visually. Okay, I'm not gonna get too in the weeds because you could argue that it's sort of a comparison. Because you're comparing where you are to where you wanna be. So you could draw like 4 and 7. And then just see how many extra there are in there.
So would that also be right or no?
That's a little less specific to the idea, but I can see you could argue that. Yeah.
Okay, because that's what I had too, and I got marked out, so.
Yeah, this one's not
Yeah,
quite
yeah.
what I needed to see, but I
Yeah,
can
yeah,
see how you
would-
could argue that, yeah.
Okay.
Alright, anything else from the quiz or from homework stuff? Okay, alright. So what I want to do today, I got a little bit to finish in section 4.2. Then I've got like group work for you guys to do. And I apologize if you wanted a new slew of animals. I just didn't have time to go find some more little clip art. So it's the same old animals coming back. So I'm very sorry. So, I think the last thing we did last time was we talked about, we did that weird thing with base 10 pieces, and then we can line them out and actually do the multiplication. Very similar to the rectangular array, the ice cube tray approach. So just to remind you guys how to do this, if I wanted to do 32 times 24, let's say. How would you represent 32 with base 10 pieces?
Just 2 longs and
Yeah, 3 longs. And 2 little units, okay? So that's like one side of the rectangular array. 24. 2 longs, 4 units. Okay. And then this is kind of nifty because you sort of, it's little internal rectangular arrays. So I've got 1 long times 1 long. And somebody remind me, what does 1 long represent numerically? 10. So this is literally 10 times 10. But visually, I want it to be this wide and this long. So I do end up making a flat there. Hey, that's interesting. I want to see if somebody leaves. Does somebody else come in? All right, and then so every one of these is a flat. Do you guys see the visual idea here? This is math, but it's not numerical. It's very visual. And of course, I get a couple more flats here. Now, if you keep looking at it as, you lay those numbers out. Now, next to the 1 here at the bottom, next to the 1 here, well, let me do this. I gotta do this every chance I get. So next to this guy, I want it to be that wide and this long. So now I'm making longs. And now here, same thing with those 4 up the top. I want it to be this long and this wide. So now I'm going to make, how you guys doing out there? I mean, this, once you get the idea. So now I got to, oh God, okay. Everybody give me a moment. And then down here, I've got 1, 2, 3, 4, 5, 6, 7, 8. Now, do you guys see how that kind of gets laid out and done? Do you guys all see that? The pieces themselves tell me how long, how wide the result should be. How do I kind of put this stuff together? Be very careful. The outer edge, let me make sure this is not part of the answer and this top is not part of the answer, yes? So, do I have more than 10 units?
No.
I've just got this many units here, yes? So I don't have to combine any of them. Does that make sense? So I've got 8. What about my longs? Do I have more than 10 of those? Oh shit. So every 10 of those, of course, makes a flat. So let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8. So I got 9, 10. There we go. Look at me counting. So there's 10. And let's see, 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. Okay. Is everybody with me so far? So now how many true longs do I have? 8. 1, 2, 3, 4, 5, 6. Oh, I'm sorry. Why am I counting these? Because I suck at drawing. 1, 2, 3, 4, 5, 6. Thank you. So I got 6 longs. How many flats do I have, considering this is another flat? Yeah, 1, 2, 3, 4, 5, 6, 7. There you go, John. And then, of course, you can just check it. Do 32 times 24. And check that it does come out to be 768. You guys with that? All right. And again, just every time we do a problem like this, just imagine having these pieces. In fact, I can have you guys do this here in a little bit on the worksheet. You can lay these pieces out and do this, and then it's all right. I need you. I think you're all with me a little bit. We're not doing 32 times 24 the normal like carry blah 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 business, but it is getting more abstract. It's not so, but it's still pieces. The pieces represent each place value. So from the student's perspective, They're not doing math, just counting shapes, right? And then you can identify what they represent with the numbers. So from their perspective, they're not doing multiplication yet. They're just counting stuff. And then you make the connection. Oh, everything you just did feeds into what we do. And then you ask them, if you had to do 3,247 times 5,489, would you want to set it up, right? Some of them might say, yeah. But still, you don't want, you get these big ass numbers, you want a more efficient way of doing it than setting up the representation. Okay. That might get. Okay. So that's the last thing we did last time. So now I want to get into, and I'm going to try to truncate this a little bit because this is very exciting. But I want to get into the intermediate algorithm stuff leading up to multiplication. Then we got to talk about division, and then I'm going to let you guys work on this worksheet. Okay. Yeah, 4-2 is like dense with stuff. 4-2's got a ton of stuff, if you haven't noticed yet. So what do you guys think would be the first step in doing this? I don't want to go straight to the way we do it, 2 times 3 times. Yeah.
You do like 40 plus 3 plus 10 plus 2.
Oh, okay. So if I were doing it using properties of numbers, then I could use like
Like you could do like
associativity, distributivity, right? I kind of want to get away from that a little bit. Okay, so I'm going to use a little bit of what you said. So like 3 times 2 is, that's insane. And then you can go 40 times 2, which is basically what you're saying, but I'm not going to write it out.
Yeah.
So you got the right idea. 40 times 2, that's insane. 10 times 3, 30. And 10 times 40, 4. So you can see how this is getting closer to our standard way of doing this. So I apologize. You basically had the right idea. Just don't write it out yet. And then you just add those up. And of course we have to carry the 1. But by the time you got into multiplication, you should have done all the idea of carrying the 1 with addition. So 6 comes down, pass it around. This will be boom, boom, boom. All right. So kind of like the next step up from there. Intermediate algorithm 2. If I do 43 times 12. And this is basically, to be honest, this is what I would call the standard. Because this is the way I did it. I'm going to ask you guys if you did this differently. So, and what's your standard way of doing this? Just how do you do this? I'm very curious. Standard way of doing this.
2 times 3.
That's crazy. And then you move over a place, right? Who put a 0 here? And who did not put a 0 there? Did anybody not put a 0 there? Okay, this is really fascinating because I noticed this. A long time ago, I used to volunteer at elementary school, and I helped people after school, and I noticed different students in different classes, some of them weren't putting the 0, and it was weird to me because that's the way I did it, way back when. So I was like, oh, and they're like, what do you want from me? That's what the teacher said. So 0, and then of course you put 3 and 4, and that's crazy. So you can see if you can get them to buy into this, it's not that far to get to there. Now the book calls standard, this is really, I really disagree with the book. The book says this is the standard way of doing things. Now some of you guys would agree with it, but some of you guys didn't put the 0 there. But it just wouldn't make sense to me, because I was brought up to put the 0 there. You guys kind of with me? So I disagree with the book. But it happens. Yeah.
I'm just confused why you went to 0. Because can't students like get mixed up if they?
I agree. I totally agree. But you can kind of see how I put the 3 here because it's an answer to this problem, so it's here. And you put the 8 here because it's an answer to this problem, so it's here. But that's just silly to me, because 12 is 10 plus 2. 10 times 43 is 430, so that, yes.
Did this with a student that I worked with,
Yes.
And what I had them do, I was like, cause they didn't quite understand that from 12 turned to a 10 once they moved over to start multiplying the 1 to 3. And
Oh, so they saw it as
so
strictly a
what I-
1.
What I did was I started scribbling out the 2 and then just put a 0. So like, okay, now you're doing 10 times 3. And so now you have to move that 0 down.
Oh, like
That
after
wasn't-
they did 86.
Yeah.
You
so
would kinda like
I
put a
would kinda
0.
put a 0 over the 2.
Oh.
And then put an arrow
Sure.
kind of
Yeah.
showing.
Okay. It does make sense. It's a little confusing because 1 times 3 is 3. So then you have to explain why that goes there. But to me, it's so much better just to remind them 12 is 10 and 2. So that's 10. That 1 is 10. All right. Fascinating the level of discussion you have about 43 times 12. But that was really neat. I was always curious about that. How many people put a 0 and how many didn't. Blah, 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 blah. Oh. Don't about that. It's a little weird. Yeah, okay, look at this. Okay. This isn't too weird. We'll do that part, yeah. We're gonna do 768 times 9. And we do it using the algorithm, using not the standard way. So I'm not carrying anything out. I would do 8 times 9. I would do 60 times 9. And then I would do 700 times 9, right? So then I end up with 6912 is going to carry a 1 pop. Okay. But if you try to do it our way, 2, carry the 7, and then what math is involved in this part?
6 times 9 plus 7.
Yeah, so there's a lot. There's 6 times 9 plus 7. There's a decent amount going on there. Right? And that's a lot to kind of like keep in the head of a student, but that's why you don't want to jump to this stage. So there's a decent amount of math happening. So you have to kind of like get them there to the point where they can do this. And then of course we end up with the same number eventually. Okay. So it's just a recognition that yes, this is the most efficient way to do it, but there's a lot going on in there that we don't stop to think about. Okay. Oh, okay. I have no idea how you guys felt about the lattice method that I showed you last time. So let me show you the lattice method for multiplication. So this one's a little bit interesting. 32 times 11, let's do. So it's going to work a little bit differently. I'm going to put 32 here, I'm going to put 11 here. So now watch this, it's kind of neat. Each little block is kind of like dependent on the numbers around it. So what's 1 times 3?
3.
That's crazy. 1 times 2,
2.
2. And then I got 1 times 3 again, and then I got 1 times 2 again. Yes? I like it. And then you just do the same thing we did before, diagonally. 0 plus 3 plus 0 is 3, 2 plus 3 is 5, and you got a little 2 there. And that's what it ends up being, is 352. Isn't that kind of neat? Here, let's analyze what's really going on. If I do 32 times 11, I get my 2, right? I get my little 2 that was down here by himself. Poor little 2. And then I get a 3 here. Yes? Y'all with me, you're like, yes, Jeff, that's what you got. Okay. And then some of you guys will put a 0 here. And then what goes here? Under the 3. That's insane. And do you see how that's right there? Okay, I just wanted to show you the connections between our standard algorithm and the lattice method.
So for that, on the like other half of the diagonal, is it always 0?
Oh, up here? Or you mean?
Yes.
Oh, up there. Can you imagine if you did 99 times 99? 9 times 9 is 81. There would be an 8 here, right? So, for example, let's do maybe not something too crazy. 99 times 34. Let's try that, right? So let's see. Do you see what's gonna happen now? Yes.
Does it matter what, like, if the 99 is first, does it matter if that goes on top of the
It really doesn't. Obviously, it doesn't matter to change the number. But I want to remind you guys, how do you represent 2 times 5 with a rectangular array? What goes here? 2. So you see how I'm kind of mimicking that? Now, the lattice array, for it to kind of work and put the things in the right place, I have to put the 99 over there. But it's still that side is going to be the first number, this side is going to be the second number.
So
That's where it's coming from, the rectangular array idea.
Okay, because the other one that you did, the 32 times 11, the 11 was second, you put the 1 on top.
Yeah, so the first number's here, and the second number's here. First number's here, second number's here. Yeah, okay. And again, we all know mathematically it doesn't matter. But just real quick, 4 times 9 is 36, 4 times 9 is 36, 3 times 9 is 27, 3 times 9 is 27, 6, what I got, 9, 6, right? Carry the 1. 13, I think. I did that really quickly. Is that what it is? That's neat. Oh, that makes sense. Yeah, that's right. Okay. Oh, did I leave something out? No, I didn't. Did I? I might have. No. Yeah, okay. So this is 6. This is 16, carry the 1. That's 11, 13, carry the 1, 3. Okay, is that cool? I guess see it. 6, say it. Do another one. Okay. How are we about this one? Okay, let's do another one. You guys give me two digit numbers.
Was so much easier.
No way.
The
No.
addition lattice method was so much easier for me.
Hell yes. Obviously. Addition will always be easier than multiplication. Give me a 2-digit number. Anybody? 62 and what'd you say? 34. Okay, so how do I set this up semi-officially here? First number goes. All right, you guys try it, and I'll catch up. All right, let's see. 4 times 6, 4 times 2, 3 times 6, and 3 times 2. So then I get 8. What happens here? 0, carry the 1, so I get 3, 13, I think, right? Carry the 1, and then I get 2. And then you can check that in your calculators. Does that make more sense?
Wait, no, that'd be 11. Yes.
Yeah, that's okay. 10, 12, 15. 10. No? It's 8?
It's 0, 6, 4.
Oh, it is a 0. I was treating it like it was a 2. I can't read my own writing. So it'll be a 1. You're right. Okay, I got you. Thank you for being your patience. Alright. But that's it's kinda cool. I don't know if you guys have ever seen the things about 3 times 2. Have you ever seen that? Is the number of times they cross 1, 2, 3, 4, 5, 6. I mean, so there's a ton of little things like that. This quickly becomes very inefficient, yes? It's really good for like small numbers, but holy shit, the minute you get 27 times 14, no, I'm not gonna do that. You guys gonna, but that would be a great way to show a student, and then you show, why do we not wanna keep doing it this way? They give them motivation to explore other ways to do it that would be more efficient, right? Okay. So, I'm gonna, I know this stuff is not the most interesting in the world. Division has some kind of cool stuff to it. I'm gonna talk about a couple things and I'm gonna shut the hell up. I think I try to have you guys do a division problem. You're gonna do one today with base 10 pieces. But if I wanted to try to do a division problem with base 10, I don't know why I feel like I've already done this, but we haven't. Let's start off with something really, really, really nice. I want to do 4/48 divided by 2 with base 10 pieces. So, let me ask you this, before we start doing this. What is 8 divided by 2? 4. Why? It's half of 8. 2 goes in 8 4 times. 2 times 4 is 8. Oh yeah, these numbers are weird. Oh my God. I got you. Sorry about that. These doors are weird. Alright,
What's that say?
who wrote that? Nobody knows what it says. So real quick, 8 divided by 2 is 4. Another way to look at it is because if you break 8 up into groups of 2, how many groups do you get? 4. So think about it. So like 4/48, that would be 4 flats, 4 longs. Good God, Jeff. Really? Alright, so break everything up into groups of 2. How many groups of 2 flats do I get? 2 groups of 2 flats. How many groups of 2 longs do I get? 2. And how many groups of 2 units do I get? 4. So again, it's a very visual representation. And they'll understand with smaller numbers the idea of the sharing model and the measurement model, right? So they'll be able to kind of like latch on to this, that they can see each grouping, each different geometric shape is its own little problem. Now, where's this going to become some trouble? Where am I going to get into some, where's this going to get a little bit harder to do?
When it's an odd number? When it's an odd number?
Odd number, well, if it was 339 divided by 3, that would be easy. But it's if the number doesn't go in evenly into any of the components, that's going to become an issue, right? Okay. So let's try a slightly more difficult problem. Should I give myself a slight? Well, let me show you. Sure. Okay, let's do this. 318 divided by 2. I don't know why I keep doing 8. That's too bad for everybody. Bless you. So what's immediately the weird thing that's going to happen? How many groups of 2 can I break the flats up into? 1. So what do I have to do with this guy? Yeah. Damn it, Jeff. Okay, here we go, everybody. Break him into lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now I'm still trying to break it into groups of 2, correct? So how many groups of 2? I'm just going to work with these 10 because 10 is divisible by 2. So I'm going to 1, 2, 3, 4, 5. Okay, beautiful. So what do I have to do with that extra long bit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9. Do you see that? 9 groups of 2 units? So 159. Okay. Let me stop for a minute. So you have that issue where any individual component cannot be divided itself by the number. So I'm going to have some left over and they kind of carry over. You break them up into the next thing. If I have any longs, I break it up into the next thing. You guys see that? Okay. You see it? You're appropriately excited. And then the last thing that can happen, very short, little quick thing, 335 divided by 3. What's going to happen here? I'm going to have a remainder. So I got 3 flats, 3 holy shits, and 5. Oh my god. They start looking like they've been out in the sun for a while. So every 3 I get 1, every 3 I get 1, every 3 I get 1, and I got remainder 2. That's right? Is that cool? Okay. Yeah, let me do this. Let me, dear God, shut the hell up. Because I think the rest of this is not represented on here, so we can do that after this. Yes. So this is kind of like a review of chapter 4 in general. And I'm very sorry again. I've got the exact same animals, so 2 bedroom. Later this month, I'm going to, of course, have some with like ghosts and such. But we got koala, we got beaver, we got meerkat, we got dinosaur, and we got, of course, can't do a van axolotl. Jellyfish got cut. I'm sorry. Giraffe? Oh, yeah? Okay. I'll keep that in mind. I'll take that under advisement. Axolotl. If you have a request to that, no, I mean, yes. So just like last time, part of this is going to involve you going up and grabbing some stuff, some pieces. You guys get one? No. I think that should work out well. 10, 15, yeah, okay, that's gonna work out pretty well. So let's see if we can do this. There should be plenty of room in here. This whole area here is free, so why don't we have meerkats come here, maybe. Meerkats? Only cats. It's a tall, skinny looking dude. Alright. Where are you? Why don't we have dinosaurs come over here? Dinosaurs over here. Future over this way. What else do we have? We have axolotl. Who's an axolotl? You're an axolotl. So, and you're an axolotl, dude. So why not right here, axolotls? Yeah. Beavers. What do we got? We got over here. Yeah, there's a lot of room over here. Come on over this way. Big toothed ones over this way. And then we got koalas. Koalas, I think that's the last group. Where's my koalas at? Alright, so I mean back there looks good, right? Back in the corner. Let's see, who do I want to be? I want to be axolotl.
So like the way I do it, it looks
I want to be dinosaur.
Call the low and the high one. So would that be for the low? It would be 40 times 90 for the low, and then for the high it would be 50 times.
Yeah.
I looked on here, we did a 342 plus 589, we did 300 plus 500, that was for the low.
Okay, wait.
Okay.
Oh,
These are
just like do
Yeah,
one.
I know.
Okay.
Okay.
Well, oh, okay, I see it now.
Doing-
So for the low one, it's gonna be.
Oh, this one. Oh, I'm sorry. Okay.
Then for the high one, it'll be 50 times. What do you like?
Breaking up, so instead of 27 and 25.
Okay.
Exactly.
Beautiful.
Like you break it up.
Kick-ass. I love that stuff. So you can see, that's a beautiful like initial step towards carrying. Yeah, I like it. And how about this guy? Not yet? Okay. Got the right number of those. Okay.
Okay, wait, let me finish this thought. Yeah, and then for the highest, it would be 50 times 200? Yep.
Man. I just want to go over a couple things. Just to shout out a group. I really like this approach they took really quickly on that 382 problem. Okay, let me see if I can get this up high enough. Okay. So just to give you the idea, I'm not going to worry about the units at the moment. So, well, sure. 382. You're all like, you made us do it. Okay, I got you. 382, right? So this kind of was really nice. Everybody did a great job. But one thing that's nifty is they did this. They went, okay, there's 3 groups. So let's literally start just putting them into groups, and then I love this. She got this one. And then you need to break those down, and I think I showed most of the groups. If you just do that for yourselves, you can get 1, 2, 3, 4 groups of 3, and then 1, 2, 3, remainder 1. So it'll be 7, remainder 1. So it'll be 127, remainder 1. And I think everybody got that in the end. Okay, I like it. And all right, one thing I want to model always as I'm walking around, and I'm never going to say that I always do this really well, is to be open to different interpretations of how to do things. You don't want to go to the point where you're letting a student do something wrong, but if the student is not completely wrong, you want to highlight what they got right and then show them why parts of it might not kind of work. I sometimes have students who do things that only work in a specific situation. That's kind of the worst, because you're like, okay, that worked, but it won't work in this problem, right? And that's kind of the worst, because they saw it work, and then you got to really get them to understand why it won't always work. Anyway, so I like that there was several different kind of approaches to these problems. Always be flexible with what you accept from students. So that was those two. This one was pretty straightforward. And of course, the idea we get from this one, the concrete representation of carrying the 1 for this guy here, right? When you did 57 plus 48. So we need to show you? Okay. So 50, I'm not going to have 7, no. So when you do 57 plus 48, 8 and 7 is 15. You get 1 more long. It carries over to the hundreds place, because now you got 10, you make it flat. So that is a physical representation of carrying the 1. Okay. I love you guys. How you do? Yeah, look, zoned out. Okay. This one wasn't too bad. I think it was this one that most people really despised. This one, the hard part is telling me what the properties are that you've used. I think most everybody identified that 25 and 4 go together. So that's what's called compatible numbers. It's also sometimes called special factors. Yeah. Oh, okay. How do you mean distribute? I'll just do it here. Say again. And do you also do it here? Ah, okay. So, here, real quick, guys. Guys, don't even write anything down. Just look at me. Everybody, look at me. What's 2 times 3 times 4? Everybody agrees 24? Everybody agrees 24. All right. And then you have somebody who says, no, I think it's 48. You all know it's 24, correct? I want you to be firm in this. And then you have a student say, no, it's 48. What's wrong with you, teach? Let me show you some math, all right? And they go 2 times 3 is 6, and 2 times 4 is 8. 6 times 8 is 48. Now what's wrong with what they just did? How many factors of 2 are present in this? 1. But now don't these both somehow have a factor? How did they each get a factor of 2 if there's only one factor of 2 to go around? You only distribute multiplication across addition or subtraction. So in this entire expression, there's only one factor of 4. Does it make sense? So if I manipulate the problem through associativity, commutativity, and by the way, I just want to let you guys know, I am well aware of the how silly, at a base level, associativity and commutativity, they both say the same damn thing. They both say, add however you want to, right? Commutativity says you can move individuals. Associativity says you can move. They both say add numbers whatever way you want to. If there's only addition, just add whatever you want to, dude. You guys kind of with me? Yes.
So if that was a plus 4, then you distribute?
If that was a plus 457, then you would distribute, right? Because it's multiplication across addition or subtraction, yeah. So this one, if I manipulate it with associativity, the ASK process, and the COM, then I get 25 times 4 times 457. So I get 100 times 457, which is, just tack on some zeros, yes? Tack on zeros. Now coming off your discussion about distribution, this second one was basically undistribution. All right, I'm going to do it the completely mathematical way, and then I'm going to show you how I talked it out with one group. By the way, the most common mistake is to think that these two kill each other. And that's, you guys understand that I did that on purpose? I wrote that on purpose that way? Because I'm evil. So I could have this discussion. I cannot subtract before I multiply, correct? Where's subtraction in the order of operations? It's at the end dash, yes? So it's the last thing I do. I can't subtract before I multiply. But I can undistribute. So whenever you see a subtraction or addition problem, but every term has the same number in it, I can take that number out. I can get it out the way. So if I take a 143 out, or if I think to myself, what did somebody have here that they distributed 143 into? How would I get this first term? What would have to be here to get this? There must have been a 25 there, minus what must have been here? 15. And what's 25 minus 15? Freaking 10, and then you just throw a 0 in. Can't like it? Now some of you guys, I'm hoping, if you feel like you were never shown this, you should be a little upset. You should be a little angry. You should be like, we're humans. We made all this shit up. We should know how this works. We should know cool shit like this. Okay. Now this one I had a couple of, what I really loved. At first I didn't like it, and then I realized what the group did. One group made it like this, 2000 minus 1874. My first reaction was, why didn't you make it 1999? And they looked at me and said, because, man, we did what you said. Because I told you guys a shortcut for this, right? Now you got to be a little careful. Let me see. You got to be a little careful about this one, but basically it's what makes this 9 and then what makes the last one 10. Yes? This is a little tricky because what do you do with those? What did you guys do with those? I think that was you guys. Did you guys do it that way? Or no? They're all like, don't look at me. Okay. So the other way to do this is to do 1999 minus, and by the way, what am I using here? Does anyone remember? Yeah, it's called equal additions. And it's like, well, we're really subtracting, but we can add negative. So we just call it equal additions. If I make it move both one way or the other way, that's equally moving it around. And the idea, of course, is the answer is how far apart the two numbers are. So I preserve how far apart they are, I get the same answer. And now I can see really easily this would be 126. Okay, maybe. This one, if I use rounding, I saw one group got this right. I don't think I looked at anybody else's, but what did somebody else do with this? How'd you round this? Yeah, okay, that makes sense. And then you got crazy. Range estimation, I saw two groups that made the same kind of mistake. There's a low and a high, correct? That's why we call it range. All right, it goes from this to this. It is very single-minded. And I know that some of you guys were trying to help it. You're like, oh, little process, let me help you. But you just do, what's the process say? You make both numbers go down. 40 times 100, so you get 4,000. And you make both numbers go up. 50 times 200, and what's that? 10,000, yeah. Now the actual answer is closer to 4,000 than 10,000, but is it incorrect to say the answer is between 4,000 and 10,000? No. It's not very confident, right? What do you think you made on the test? Somewhere between 16 and 100. Yes.
For the average grade, we also do like 45 times 100, or no?
Oh,
For range.
Range, you would average these two together, right? You're kind of doing a combination of rounding and range when you do 45 times 100? Yeah. Yes?
So for the low estimation, we can't round it to 45 and 100. You want it to go lower.
Yeah, the process, the actual just range estimation process is sometimes silly. But it just is always the same. Make both numbers go down, make both numbers go up. And you round it to the nearest roundest number. Yeah, okay. Let me stop for a minute. Alright. How about I didn't look at this one at all for anybody because I suck. But did anybody have any trouble with this one? Did everybody try this one? I didn't even look. Okay. So 112 plus 174. It's been a hot minute. Am I making this too much?
Yeah.
Wait. It's been a minute since I did lattice method.
Like a rectangle with the split two.
Yeah. So then 112. Oh yeah, I'm being silly. 112. 174. Yeah. Okay. I was marrying it with the what do you call it? Multiplication. So then 2 plus 4 is 6. It's crazy. 1 plus 7 is 8, and 1 plus 1 is 2. I was going to put a multiplication on here. I forgot. And of course, then you get 286. So that one wasn't very interesting because there was nothing that kind of like carried over. Okay. This one, there's a little trouble with this one, but I like that some groups did it one way, some groups did this, and some groups did this. But of course, either way you do it, get 75. So the idea is compensation is one person gives to the other. So I think of these numbers as being people, one has 27 bucks, the other one's got 48. I can give the 48 2, or I can give the 27 3. I try to make it round, because then it's easier to do stuff. And then this is another example of Jeff just really doing great. And then the idea here is 7 is the one you want to build on. It doesn't really matter, but 7 base 8 plus, I could break 4 up into 1 base 8 and 3 base 8, because this makes the base, and then I get 13 base 8. Yes?
Could it be 3 base 8 plus 10, 8?
3 base 8 plus...
Give 1 from the 4 to the 7 to make it...
Yeah, that's basically what I did. I just kind of wrote it out, yeah. I kind of turned them around. Yeah, it's my bad. But I basically wrote that out, yeah. Gave 1 from this one to this guy, make him 10. Okay. And then this one, I think we all eventually got it, but it's basically, it doesn't work the other way, because if I wrote this out, which I'm not going to write out completely, but blah, 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 over 2a, each thing gets divided by that. So if the thing that, I'm sorry, you guys should tell me you can't see shit. If I write the top out over the bottom, you can see that each thing gets divided by the bottom. So what that boils down to is I distribute this division to each. And then literally each term just loses a factor 2 and loses an a. So 12 becomes 6, I lose an a. 4 becomes 2, I lose an a. 6 becomes 3, I lose an a. Poor little guy. Okay. I like it. Okay. There's one, yeah. So any questions from that? All right, I want to do something a little different. I want to talk about chapter 5 a little bit, and I'm going to let us out of here. And the thing I want to talk about from chapter 5, let's see. Does anyone still have like base 10 pieces? Oh. Let's see, I might as well talk about a few things. All right. Thank you. So let me ask you guys what you think about when I say the phrase prime numbers. What comes to mind when I say that?
That can only be made by themselves and one.
Yeah, you can only break them up as themselves and one. That's the only way you can factor it using whole numbers, right? So for example, is 18 prime? No, because I can do 1 times 18, but I can also do 2 times 9 and 2 times 6 and blah, blah. Okay. What do we call a number if it's not prime? Does anyone know? Starts with a C. Sometimes back in the day, you'd have in the backyard, you have a big pile of all your organic waste, and you call it this. Yeah, so this is a composite number. Because it's composed of more than just one in itself. Sometimes math people pick decent words for things. Most of the time we don't. So can somebody give me like the first few prime numbers? Even before that? 2, yeah, 1 is weird. We call 1 the unit number. It's not really considered to be a prime. 2, 3, 5, 7, 11 there. Okay, blah, blah, blah. You got it. All right. And the bigger they get, the harder it is to tell if it's prime. Yes? So one thing that I'm really excited about with this section, this is one of my favorite sections. I'm going to talk to you a little bit more about how do you tell if a number is divisible by 3, by 4, by 5, by 6, by 8. 7's got a weird ass rule, but the book didn't even talk about it. It's like, I don't know. But before I do that, I want to make sure there was one other thing before I jump into that. Oh, yeah, okay. Is this where we do that? That's so cool. I don't think so. Darn it. Maybe it is. No, maybe I can show you anyway. Okay. So here's one other thing. There's a, let me see how I want to say this. Yeah, okay. There's an idea about dividing into evenly. We all understand this idea. So like, for example, 2 divides into 8 even. So we would say 2 divides 8. This is how we would put that. This is read 2 divides 8. What that means is it divides into 8 evenly. So for example, does 3 divide 31? No, so I'd say it does not divide 31, because we're all very creative math people. We say a line through means not. Okay, I like it. So far, so good. Okay, so that's what that means. Let me ask you a more conceptual question. If 6 divides A and 2 divides B, does 12 divide AB? Alright, so why do you think that's true? So 6 divides A, that means that A times something is 6. 2 divides B, that means that 2 times something is B. And then when you get A, B, so can you come up with a counter example? Like 6 has got to divide into a multiple of 6, correct? So we know that A is a multiple of 6. And B has to divide, B has to be a multiple of 2. So just to show you how to kind of like prove this. So just to show you your intuition was correct. If I do A times B, what do I get? It's pretty cool this, by the way. If 6 goes into A, that means A is 6 times something, yes? And if 2 goes into B, that means B is 2 times something. So then what's A times B then? It would be 12 times something. So 12 definitely goes in. Okay, good. So you can get kind of like conceptual questions about divisors, this division idea. You're gonna see some of those in the homework, and obviously on my test. Okay. Then there's also this one extra little idea. Yeah. Okay. You guys remember doing prime factor trees? So like if I had to do a prime factor tree for 24, just help me out real quick. 6 times 4. 2 times 3. It's kind of funny. As a math teacher, I hear this. Oh, sorry. So what's a better way to write 2 times 3 times 2 times 2?
2 cubed times 3.
Yes. I call this, because I'm weird, I call it the DNA of 24, because those only make 24, and 24 can only break down to that. Okay. So every single number has its unique prime factorization. All right. So here's the cool shit. Everybody knows how to tell if a number is divisible by 2. What's got to be true about the number? It's got to be even. Yeah. So 2, you're awesome. 2, even, check. I can't remember now if I told you about 3. Did I tell you guys about 3? How to check if something's divisible by 3? No. Here's the check. Does anyone know how to tell if something's divisible by 3 besides putting your calculator and seeing what it says? If all the digits add to
Is it something that's divisible by 0?
a multiple, you're thinking about the rule for 9, a multiple of 3. This is such a cool idea. And this is an example of, if you don't think you've ever been told this, you should be a little angry. But you gotta remember, your memory is not the best when you go back to when you would have been told this for the first time. So for example, is the number 15426, is that divisible by 3? When you add up all the digits, what do you get? 18. So it's divisible by 3. If I just look at the damn number, I would say no. Just looking at it, and go, nope. But sure enough, 3 goes into that. Does somebody have their calculator? 3 would be 5142. 5,142. Yes? Okay. Okay. I kind of want to just mention this. We're going to get to 9 in a minute, but 9 is very similar to this. And why does that make sense? Because freaking 9 is a multiple of 3 itself. So 9 has a very similar rule. The numbers don't all have the same kind of rule, though. 4. Normally people know 9. Like, what's 9 times 7?
66.
And what's 6 plus 3? 9. So a lot of people kind of have heard that rule, but less and less over time. Everybody used to know that, and now I'm like, not everybody. The rule for 4 normally isn't known. Does anyone know how to tell if something's divisible by 4? Let me see if you guys really understand this. What is 4 times 25? 100. So does 4 go into 112? Of course it does, because it goes into 100 and it goes into 12. You guys see that? Therefore, if you keep going with that, 4 goes goes into every damn number where the last two digits are divisible by 4. And I did say digits. The last two digits are divisible by 4. So for example, I can just go, so let me put the rule. Last two digits divisible by 4. So for example, 1, 2, 9, 8, 5, 5, 5, 4, 3, 9, 7, 6, 4, 4. Is that divisible by 4? Yeah, you usually look at the last two digits. Blah, 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 blah. Okay. And again, if you remember that 4 goes into 100, that means 4 goes into 200, 4 goes into 300, 4 goes into anything 100. So I just need the last two digits to work. That's why that works. Okay. Maybe. Some of you guys look appropriately excited. What about 5? Everybody knows 5. I'm not going to spend any time on 5. How do you know 5 goes into something? Ends in 5 or 0. Yeah. Maybe alright. Ends in 5 or 0. What about 6? Okay, 6 is the just to solidify your minds that I'm weird as shit. 6 is fascinating. Anybody have a clue? What is 6 made of? So doesn't it make sense that in order for something to be divisible by 6, it must meet the rules for both 2 and 3? What's the rule for 2? It's got to be even. What's the rule for 3? Has to add to be a multiple of 3. So for example, this very first number, is this, get out of there, is this divisible by 6? Yes, because it's even, and they all add up to be a multiple of 3. You guys with me? Now, is everybody really with me? If it's even, 2 goes into it. If all the digits add up to be a multiple of 3, 3 goes into it. If 2 and 3 both go into it, freaking 6 goes into it. Does that make sense? That only works if the two numbers I'm considering, in this case 2 and 3, oh boy, are called what's relatively prime. 2 and 3 are relatively prime. Do they share any numbers? No. For example, do 4 and 8 share any factors? Yeah. So they are not relatively prime. So I can't tell if a number is divisible by 32 if it meets 4 and 8 because they don't, because they share each other. They have parts of each other. See, so their rules aren't exclusive, aren't like independent. Maybe. So if I want to know if something's divisible by 15, what rules does it have to meet? Are 3 and 5 relatively prime? Do 3 and 5 share any factors? No. There's nothing that goes into 3 that also goes into 5, correct? That means to figure out if it's divisible by 15, it's got to end in 5 or 0, and it's got to add up to be a multiple of 3. If it does those two things, 15 goes in. Let me stop for a minute. I don't know if you guys are really with me. Some of you guys are looking like, say it's over. Not yet. Love you guys. 7, weird as shit. Poor 7 dude, weird as shit. 8, I'm not going to worry too much about 8. 8's like 4. That makes sense, yes? Because 8 is twice 4, so it should. But it's the last 3 digits have to be a multiple of 8. So that one is kind of difficult to tell because not everybody has multiples of 8 memorized. Yes? I don't, so I'll blame you if you don't. 9 is the same rule as 3 except it's 9. So all the digits have to add up to a multiple of 9. So the very first number we did, does 9 go into it? I don't know if you guys remember. They added up to be 18, so yes, 9 goes into it. All right. Say again? I'm sorry.
I thought it was all the digits had to like.
All the digits have to be a multiple of 9. Yeah. For the 2-digit numbers, they add up to be 9. But what about 99? What's 9 plus 9? 18. Now, what you could do, 9 plus 9 is 18, 1 plus 8 is 9. If you take it all the way down, then it becomes 9. Or you can just stop and see it's a multiple of 9. Alright guys, I don't blame you. That's enough. I'll see you guys. Have a good weekend. box it out, put like correction. Yeah, you're really clear what's new. See again? Oh no. Okay. Is this? What is this? Oh, I guess somebody turned that off. Okay. Turn this guy off.